Have you ever looked up at a sky ablaze with a brilliant star-like object and wondered about its secrets? That's Venus, our closest planetary neighbor. Brighter than any star, Venus has captivated humanity for millennia. Ancient civilizations marveled at its brilliance, weaving tales of gods and goddesses around its celestial dance. But what if I told you this celestial beauty harbors a deadly secret, a truth so extreme it makes colonizing Mars look like a walk in the park? Venus, our sister planet, is a hellscape. It's true. Beneath Venus's mesmerizing beauty lies a planet trapped in a runaway greenhouse effect. Its surface is a scorching furnace, hot enough to melt lead. The atmosphere? A thick, toxic shroud of carbon dioxide, a suffocating blanket that traps heat with terrifying efficiency. Why then, with all these challenges, do we still dream of conquering Venus? Because beneath the danger, beneath the unforgiving conditions, lies a scientific mystery waiting to be solved, a puzzle that could hold the key to understanding our own planet's fate. Imagine standing on the surface of Venus. You wouldn't need a spacesuit, you'd need a submarine. The atmospheric pressure is crushing, 90 times greater than Earth's. That's the equivalent of being 3,000 feet beneath the ocean's surface. Think about the deepest depths our submarines have explored, the immense pressure exerted on those steel behemoths. That's your everyday reality on Venus. Even if we could design a structure to withstand this pressure, the sheer force exerted on astronauts would be unbearable. The air itself is a heavy, stagnant ocean, a crushing weight that would make every movement a Herculean effort. Just imagine trying to take a step, to lift an arm, to even breathe under such immense pressure. It's a hostile environment that pushes the limits of human endurance and engineering ingenuity. Let's talk about temperature. Venus makes even the hottest deserts on Earth feel like a winter wonderland. The average surface temperature hovers around 867 degrees Fahrenheit, hot enough to melt lead and turn zinc to liquid. Remember those captivating images of rovers exploring the Martian surface? On Venus, those rovers wouldn't last minutes, their delicate electronics fried to a crisp in the unimaginable heat. The surface of Venus is a furnace, a relentless inferno that challenges our very notion of habitability. Forget about liquid water, forget about life as we know it. Venus's surface is a testament to the destructive power of a runaway greenhouse effect, a stark warning from a planet that may have once resembled our own. If the heat and pressure haven't deterred you, let's talk about the rain. On Venus, it rains sulfuric acid, and not the gentle drizzle we experience on Earth. We're talking corrosive downpours, capable of stripping paint from a car in seconds. Imagine a sky perpetually choked with thick yellow clouds, a constant reminder of the toxic rain that never quite reaches the surface. The heat is so intense that the sulfuric acid evaporates before it hits the ground, creating a vicious cycle of heat, evaporation, and acidic precipitation. It's a hostile dance of elements, a chemical maelstrom that makes the idea of venturing outside without the most robust protection imaginable a recipe for disaster. Time on Venus is a strange beast. A single day on Venus, the time it takes for the planet to rotate once on its axis, lasts a whopping 243 Earth days. That's longer than a Venusian year, which clocks in at 225 Earth days. Imagine living in a world where the sun crawls across the sky, where day and night stretch on for what feels like an eternity. The psychological impact of such prolonged cycles of light and darkness would be profound. Our circadian rhythms, our internal clocks, are finely tuned to the 24-hour cycle of Earth. On Venus, these rhythms would be thrown into disarray, potentially wreaking havoc on sleep patterns, hormone levels, and overall mental well-being. Let's not forget the journey itself. Venus may be our closest planetary neighbor, but it's still a treacherous trek across the vast expanse of space. Current technology would require months to reach Venus, a long and lonely voyage fraught with its own set of challenges. The isolation of deep space, the confinement of a spacecraft, the constant exposure to radiation, these are just a few hurdles we'd need to overcome. Astronauts would need to be psychologically and physically prepared for the demands of such a grueling journey. And once they arrive, there's no quick return. A mission to Venus would necessitate a long-term commitment, with no room for error. It's a daunting prospect, even for the most seasoned space explorer. Let's say we do make it to Venus. How do we survive? Building a colony on a planet with such extreme conditions would require extraordinary engineering feats and materials that can withstand the relentless heat, pressure, and acidity. We'd need to develop new materials, new technologies. Imagine self-repairing structures, robots that can function in extreme heat, and life support systems capable of scrubbing the toxic atmosphere. It's a monumental task, but not necessarily an impossible one. It would require a paradigm shift in our thinking, a level of innovation that pushes the boundaries of human ingenuity. We'd need to create a closed-loop ecosystem, a self-sustaining bubble that can provide food, water, and breathable air. It's a challenge that would test the limits of our scientific knowledge and our ability to adapt to the most unforgiving of environments. So, is Venus a lost cause? With all these challenges, you might think Venus is a lost cause, a planet destined to remain forever shrouded in its toxic embrace. But despair is not in the vocabulary of exploration. The very challenges that make Venus so daunting also make it an irresistible target for scientific inquiry. By studying Venus's runaway greenhouse effect, we can gain a deeper understanding of our own planet's climate and the delicate balance that makes life on Earth possible. What lessons can this hellish world teach us about our own planet's future? Can we unlock the secrets of Venus's past, a time when it might have been a more hospitable world? Venus is a stark reminder of the power of nature, a cautionary tale writ large across the solar system. But it's also a beacon, a challenge to our ingenuity, a call to explore the unknown and unravel the mysteries of our cosmic neighborhood. While colonizing the surface of Venus seems like a distant dream, the future of Venusian exploration is far from bleak. Scientists are already envisioning innovative solutions, such as floating cities in the upper atmosphere, where temperatures are more forgiving and the pressure less extreme. Imagine massive airships, their gondolas housing laboratories and living quarters, suspended above the scorching hellscape below. Imagine robots deployed to the surface, collecting data and sending it back to the safety of the floating cities. These are not mere flights of fancy. They are the seeds of future exploration, the first tentative steps toward unraveling the secrets of this enigmatic world. And as we push the boundaries of technology and innovation, who knows what other possibilities might emerge? The challenges of colonizing Venus are undeniable, but they are not insurmountable. The human spirit of exploration, our innate drive to push beyond the known horizons, is a powerful force. It's what led our ancestors to cross oceans, to conquer mountains, to venture into the unknown. And now, it's what compels us to set our sights on the stars. Venus may be a hellish world, but it's a world that holds secrets, secrets that could unlock a deeper understanding of our place in the cosmos. So, let us continue to explore, to innovate, to dream of a future where humanity's reach extends beyond the confines of our home planet. Let us dare to unravel the mysteries of Venus, not because it is easy, but because it is hard, because it challenges us to push the boundaries of human ingenuity and to embrace the unknown with courage, curiosity, and an unyielding thirst for discovery.